Hello, dear students. So my name is Apratim Chatterjee, and I'm an assistant professor in the Department of Electronics and Communication Engineering in SIST. So as you can see in front of you, our topic of discussion is microwave communication. So it's a unit in the paper called Digital and Microwave Communication Systems. So this is what we will be discussing now in this video. Now, I won't make the video too long. So, the entire syllabus, I will be covering it in a few small parts in the videos, and I will be uploading them shortly. And you can see the entire syllabus that will be covered in those videos. So let us start very carefully because this particular unit it requires a very in-depth understanding of the concepts and of course knowing of the facts. These are all very important things for exam and for your knowledge as well. So yeah, let's start today's class of microwave communication. So let me first start with this name that is given to this particular type of wave. They are called microwaves. Okay. Now microwaves, these waves especially, they are the backbone of our telecommunication systems. Okay. I mean the word that we hear more often, like the word which is called globalization. Okay, this has been possible because we can communicate easily from one place on the earth to the other place. So these are entirely possible because of the radio waves. We call them the radio waves, and these microwaves actually they are a small portion of this radio spectrum. Okay, so you guys have heard of this name of radio waves. You all know what are radio waves, but microwave, this is something new to you guys. So let's understand the meaning of the word microwave. Is this wave called a microwave? See, micro means something which is very small, right? So is this wave very small? Is this what is the name coming from? Microwave. See, so the word micro here actually it signifies the wavelength of these particular waves. Okay, we will see later on. I can just tell you right now that the range of the wavelength, okay, these microwaves, their range of the wavelength, they vary from 1 meter to 1 millimeter. So you can see that 1 meter to 1 millimeter wavelength is very small. It's a very small wavelength, right? It's a very short wavelength. So because of this shorter wavelengths of these particular waves, they are given the name of microwaves. Okay. Now, so wavelength or the range of the wavelength is 1 meter to 1 millimeter. Now you would be interested to know about the frequency range of these waves. I mean, what is the range of frequencies in which these microwaves operate? So the frequency range goes like this, and it is easy to remember. So it is 3 megahertz to 300 gigahertz. Okay, so as you can see, because the wavelength is so small, the frequency has to be very high because there is a inverse relationship between the frequency and wavelength of any wave, right? So the frequency, these microwaves, they are very high frequency waves. They are very high frequency waves. Okay, so the range is 300 megahertz to 300 gigahertz. This is the range of frequencies in which the microwaves work. Now, as I mentioned in the beginning, just a few minutes before that, microwaves are part of radio spectrum. Microwaves are part of this radio spectrum. Now, what is the range of frequency of the radio spectrum? If you can just note down the radio spectrum, then you will understand why I said that microwaves are a part of the radio spectrum. So the frequency range of radio waves are they start from 3 kilohertz to 300 gigahertz. So now I think you guys can see it clearly that the microwaves are starting from 300 megahertz, and they will and the range is till 300 gigahertz, right? Now the radio waves, they are starting from 3 kilohertz and their range is still 300 gigahertz, same as the microwaves, right? So from this, looking at these two frequency ranges, we can conclude very easily that the microwaves are a part of the radio spectrum. I mean, to be more specific, those radio waves which have very high frequency, they will be given the name, they will be called microwaves. So any radio wave of frequency, let's say more than 300 megahertz, they can be called microwaves. All right. Now, microwaves, I mean, if you just, I mean, all of us in our cell phones, we use this Bluetooth, right? Um, can you guys know about the frequency of the Bluetooth? It's 2.4 gigahertz. This is the frequency of a Bluetooth. Okay, so it's in gigahertz. So that means that wave when we by which we are operating our Bluetooths, that wave is can also be called a microwave. Okay, and our commercial band, which ranges from, I will let me come to let me show you the spectrum. Yeah, see our commercial band, so it's from C band. It starts from 4 gigahertz to 8 gigahertz. That's our commercial band. Okay, and there are X band, there are Q bands, there are K bands, which are used for satellite, radar, and other and various other telecommunication operations. So this is how we are dividing the spectrum, and we are giving them this name of these bands. So these spectrum, you can see the spectrum which is starting from 300 megahertz and which will end till which can extend till 300 gigahertz. This entire frequency band can be called, they can be called microwave region. Okay, at the microwave region, they are a small portion of the entire radio spectrum. And if you can clearly see from the diagram that as we are going on, as the frequency is increasing, this is how the wave will look like. The frequency is going on increasing and the wavelength is going on decreasing. Okay, because there's an inverse relationship. Fine. Now the microwaves, we have got an idea about what are microwaves. We will go into more details in the as we will proceed with the entire paper. Now the application areas where we can use microwaves, one I told you about the Bluetooth and our commercial band microwaves. So microwaves can be used, are used in any communication systems which will require telecom, I mean sending signals at a very distant places, with signals where they need to cover large distance. They are used in satellite communication. There are some of the microwave, you will see that there are some specific microwave devices which are used in satellites in as transponders, and also in radar communications. So there are multiple and various applications of microwave. Our entire communication system is built on, I mean the microwaves, they form the backbone of our communication. All right. Now, so this is how the any electromagnetic wave looks like. I just wanted to show you this picture. I'm sure that you guys already know that what's happening over here. I mean, there are the electric field and the magnetic field. They are they are mutually perpendicular to each other, and they are also perpendicular to the direction of propagation. Okay, so they are oscillating, and they are the energy which is oscillating between the electric and the magnetic field. That energy is propagating in this direction. Okay, all right. uh, Now our topic will start from these devices, these devices which you can see in front of you, I mean in the screen. So these devices, they are like, you can see the diode, you can see the triode, you can see pentode, right? The what are they called, what are these devices called? These devices are called vacuum tubes. These devices are called vacuum tubes, right? So what is inside a vacuum tube? So there are let's say talk about a diode. So there is a cathode and there is an anode. So electrons are emitted from the cathode and they travel towards the anode. Okay, and once the electrons reach the anode, so this is how we are getting an current at the anode terminal, and we control the voltage so that we can control the current. in this sense. So basically, these conventional vacuum tubes, they are basically they are voltage controlled devices, and the electrons flow through the vacuum, as I told you, and they contain a cathode and anode, and there can be one or more electrodes. We will see later on, and they are called grids. They are called grids. Okay, so and why are we calling them conventional tubes? See the very last point where it is saying that conventional tubes, they are used below microwave frequency. What does it mean? It means that these conventional vacuum tubes, they cannot be operated in the microwave region. They have certain limitations. They will always fail if you try to operate them in the microwave frequencies. But why? So the our understanding of this particular unit of microwave communication, it starts from this very question, that why conventional vacuum tubes like these ones, diode, triode, pentode, why they fail at the microwave frequency. So this is what we are going to start our discussion today, the limitations of these conventional vacuum tubes. Okay, and especially we see these limitations as we increase the frequency above 1 gigahertz. So what are the main reasons? So here you can see that main reasons are, one by one I will go into all the reasons. So first is the interelectrode capacitance, then we have lead inductance, transit time effect, gain bandwidth product, skin effect, radiation losses, and dielectric losses. All right. So and now in this particular video, as I told you, I want to keep it short. I will keep all of the videos short, and we will cover entire syllabus in this small portions of the videos. So for this particular session, I will focus on one of the, let's say the one of the important limitations or causes why conventional tubes don't work in the microwave frequency. So let's start with the very first one, which says interelectrode capacitance. So what is interelectrode capacitance? I'm going to draw a circuit of a triode, and I will explain what happens in that particular vacuum tube in the microwave region. So let me draw a triode. So what does a triode consist of? It consists of a positive plate called the anode. We can give it the name as a plate. Okay, so I'm denoting it as P. It has a negative terminal, a negative electrode, which is called the cathode. I'm giving it the name as C. And there is one more electrode, which is called grid. It's called grid. Okay, so these are the three electrodes of a triode. That's why it's called the triode. Tri means three. There are three electrodes at the plate, which means which is just the anode. Then we have the cathode, and we have the grid. Okay, so what happens is the electrons will flow from the cathode to the anode, and the grid controls the voltage. Now these three electrodes, they are not connected directly. I'll repeat, this is very important. Note it down that these three electrodes, they are not connected directly. All right. So how are we connecting these electrodes then? So we are connecting these electrodes. We are placing capacitors between each of these electrodes. We are having capacitors between each of these electrodes. All right, so this is how it will look like. Now let's give the capacitors the names, so that will be easier for us to understand in the future. So the capacitor between the grid and the plate, let's call it CGP. All right, the capacitor between the plate and the cathode, let's call it CPC, and the capacitor between the cathode and the grid, let's call it CCG. So this is how the our triad will look like. All right, so now what's the big deal over here? What's going to happen now? Focus on the capacitors. Okay, so capacitors basically, so the capacitors, they will have a reactance. I hope you all know what is reactance. Is basically the opposition to the flow of current due to these capacitors, and also inductors. Now the reactance due to capacitors, I can write it as XC. So XC is the reactance due to the capacitors. So XC is equal to, I will give you the expression of XC. It is 1 by 2 pi FC. Very, very important, this expression. XC is equal to 1 by 2 pi FC. You can see it over here, right? So what is the, look at the relationship between the reactance and the frequency. Yes, I'm sure that many of you can guess it. So reactance and the frequency are in inverse relation. That means if we go on increasing the frequency, the reactance should decrease. Okay. So let's say that we are increasing the frequency. So that means the reactance would go on decreasing. So now here happens the problem. What happens over here is, see, if the frequency is going on increasing, that means we are entering what? The microwave region. Microwaves are of course, by definition, they are very high frequency waves, right? So when if we want to operate these triode in the microwave region, because of the high frequency, what will happen is the reactance due to the capacitors will go on decreasing. Now if the reactance of the capacitors goes on decreasing, so it will be like they are not even there. The reactance is going on decreasing, then that means that it will be like they are not even there, right? So then what will happen is the grid plate and the cathode, these three electrodes which are not connected directly but through those capacitors, now when the reactance will become so small, there will be short circuit between these electrodes. There will be a short circuit between these electrodes. Okay. Now this will cause, definitely will cause a big problem, isn't it? So we don't want a short circuit in this particular circuit. But eventually, if we use high frequency waves, especially when we are using the microwave signals, because of the high frequency, the reactance of the capacitors is bound to decrease, and when that happens, there will be short circuit between the electrodes. Okay, so that is why we cannot use these conventional vacuum tubes like a diode, triode, or pentode. We cannot use them in the microwave region. So what's the main problem over here? The main problem is because of the capacitors. Now these capacitors are between the electrodes. So because of this capacitor, this effect, it is called interelectrode capacitance. So this interelectrode capacitance is the main problem because of which we cannot use, not the main, one of the main problems because of which we cannot use a conventional vacuum tube in the microwave region. Okay, so I hope that this is clear to you guys. Now we discussed one of the reasons. We covered interelectrode capacitance. All right. So let me keep this video till over here, and in each of the videos I will cover these points. See, the very last points I will give you guys as an assignment. As also, I can tell you about skin effect, and then I can give you an assignment to find out what causes skin effect. We'll come to it later on. And radiation losses and radiative losses would not take so much time to explain to you guys. Now these the second and the third points, the lead inductance and the one after that, transit time or angle effect, this needs to be understood carefully. Okay, so I hope that interelectrode capacitance, the reason why conventional tubes cannot operate in the microwave region, that is clear to is very much clear. In the next video, in the next session, I will discuss about this effect called lead inductance, and again lead inductance also plays a role why conventional tubes we cannot use in the high frequencies. So we are going to look into that in the next video, in the next session. Okay, so I hope you enjoyed the video. Stay tuned. I'll be back with rest of the topics.